Welcome friends. In our earlier class, we were talking of how to handle uncertainty in our inventory management, and in uncertainty related to inventory management, we discussed that largely uncertainties are in the area of demand side. That when we are having some kind of uncertainty in consumption rate, that is to be handled, and for handling that uncertainty we have a very important tool which is known as safety stock. We discussed that how are we going to calculate the safety stocks. We discussed some of the measures in the field of uncertainty like product fill rate, order fill rate, and more importantly cycle service labels. We discussed that how cycle service labels can be done with the help of normal distribution function in the Excel. Now, you can calculate cycle service label, you can also calculate what should be the reorder point on the basis of these CSL calculations. All those things we have done in our last session. Going further, it is also possible that there may be uncertainties related to supply side also. There is a demand side, there is a supply side. Supply side uncertainties more commonly are possible in two ways. In all our previous classes, we have assumed that whatever we are ordering, the supplier is giving the same quantity. You are ordering 500 units, supplier is giving you 500 units. But you can always assume that supplier can give short supplies also. If you are ordering 500 units, supplier may give you just 400 also, because supplier has also done commitments to many customers and only some limited quantity is given to you. That is quite possible. Second is, supplier is saying you that I am going to deliver you in 10 days. You give me the order, I will give you in 10 days. But supplier may take 12 days to deliver. So, there are uncertainties related to supply side also. Then in many kind of inventory issues, when you are procuring the items, there are possibilities that your supplier may offer you some deal also. Okay, you are giving me the order of let us say 500 units, I will charge you 5 rupees per product. But if you give order of let us say minimum 1000 quantity, I will charge 4 rupee 50 paisa. And if you give minimum order of 2500 units, I will charge only 4 rupee per unit. So, these type of situations are also very common in our day to day life. Even in your personal life also, when you go to vegetable markets, you see these kind of quantity discount situations, where a vegetable seller, a fruit seller may charge different rates if you are going for a bulk buying. So, if you are getting a situation of quantity discounts, how are we going to change our decision making in light of that? And then there are some situations where you are producing on one side, you are receiving the order on one side, and you are simultaneously consuming them also. Like in our EOQ model, if you remember, all the replenishments were happening instantly. A single straight vertical line was representing the replenishment line, but it is possible that replenishment may happen over a period of time, and during the period of replenishment consumption is also happening simultaneously. So, these types of models are known as production lot sizing models or economic production models. So, how are we going to decide the economic order quantity which we say in this particular case as economic production quantity EPQ? That is also we are going to discuss in this particular class. So, as I said, the first thing which we are discussing, that is the supply side uncertainty. So, if you see this model, here we have this ROP, this is the ROP. Now, here we are having this fixed lead time, but it is also possible that this lead time is also variable. There may be a mean lead time and then there is a standard deviation of lead time. So, you may have a very complex situation. You already have a mean demand that we discussed in our last class and standard deviation of demand, and you also have another variable, the mean lead time and standard deviation of lead time. So, if you want to calculate the overall demand during the lead time, then you simply multiply this with this mean lead time with mean demand. But if I want to calculate the sigma of demand during lead time, sigma of demand during lead time, this is calculated with this formula, where if you see this formula, we have two terms. One is taking care the variations of the demand and another is taking care the variations of the lead time. L into sigma d square plus d square SL square, where SL we are representing as this sigma LT is equals to SL. So, this is how we are going to calculate the standard deviation of demand during lead time. DDLT stands for demand during lead time. So, these are the calculations, and then once you have DL and sigma DDLT, you may recall what we discussed in our previous class, that normal distribution curve will come into the picture. This is DL, and then you have one standard deviation, two standard deviation and three standard deviation. These are sigma DDLT. This is plus 2 sigma DDLT and this is plus 3 sigma DDLT, and so on the left side of this DL also. So, here if I have a simple illustration to explain that how these calculations will take place, we have weekly demand of 2500 units, standard deviation of this demand is 500, lead time is 7 days, L is lead time, and standard deviation of lead time is also 7 days. The mean lead time is 7 days, this is in fact actually mean lead time or average lead time, and this is the standard deviation of lead time. So, our average demand is 2500, that is per day demand, into the 7 days 17,500 units, and then we calculate sigma DDLT using this formula, and that sigma DDLT is also coming to be 17,550, and then we are considering a CSL of 90% for this particular situation. So, if you remember, we can use normal inverse function in the Excel, and that normal inverse function of this multiplied by sigma DDLT will give you the safety stock 22,491. Now, I have a question for all of you, that what should be the use of this safety stock. You can see that in the bottom line we have mentioned this point, that daily demand is around 2500 units. If I divide 22,491, it is approximately 9 days. So, meaning is I am keeping a safety stock for handling the situation up to 9 days. Up to the 9 days I can handle the situation, and it is possible that there may be some delay in the supply side also, and there may be some increase in demand also. So, the cumulative effect, if I say, is possible to handle for let us say 9 days if there is only variations on the lead time, or if there is a increase in daily demand, because daily demand can also have a variation of standard deviation 500 units. So, in that cumulative manner, if 22,491 that safety stock is kept, I will be able to achieve on an average a CSL of 90%. That means 90% orders will be fulfilled from the available inventory in my stocks. 10% customers may not be able to get orders from the available stock. That is the impact of supply side and demand side uncertainties. Then another situation we want to discuss, as I said in the beginning, that is the quantity discount. In the quantity discount situations, you are given different price ranges P1, P2, P3, P4, depending upon your order quantity. Prices will decrease as your order quantity is increasing. So, your order quantity Q is inversely proportional to the price. That is the idea of this quantity discount models. You charge more price, order quantity will be less. You charge less price, order quantity may increase. Now, here the question is, sometime when we want to take the benefit of these quantity discounts, we may not be ordering the EOQ quantities, because we want EOQ quantity which will minimize my total inventory cost. This price benefit is not coming on the inventory cost, price benefit is coming on the material cost. And if you remember our first class of this inventory discussions, our EOQ calculation is basically based on holding cost and ordering cost. So, in this case, if some discounts are available for larger purchases, how to incorporate this benefit? Ultimately, please remember one more thing. Though we are discussing many analytical related decision making, and when we started this inventory management discussions, we said that we want to minimize the total inventory cost, but that is not the correct picture. We want to minimize the overall cost of our operational activities. Inventory is just one subset of that, but if I am getting a bigger benefit because of larger purchase quantity, then I may sacrifice the benefit of inventory cost. So, here I have a more holistic model where I will include the material cost as well as the inventory cost to see that whether the benefits are really significant. If the benefit because of quantity discounts or bigger purchases can give me some benefit at the cost of increased inventory cost, I will still love to go for those kind of benefits. But if by increasing the lot size, if by increasing the purchase quantity, the benefits are lost, if there is no benefit, in fact my total cost is increasing, I will not like to go for quantity discounted purchases. So, in this way I am going to discuss that how are we going to handle these quantity discount cases. In the quantity discount case, we have a very systematic process of handling the inventory calculations. Here you are having let us say 2-3 prices. We have a requirement of a product which is coming at the rate of let us say 2000 units per year, that is the R. I am using the same symbols which I started in every session. So, I am not repeating what is the meaning of R. It is 2000 units per year, that means our annual demand. Now, the supplier is ready to give me three different prices. One price is rupees 2, so you can note down them as rupees 2 for less than 1000, rupees 1.90 for 1000 to 1999, and rupees 1.86 for more than 2000, more than or equal to 2000. So, now I am getting a quantity related prices, that if I am ordering more quantity, the supplier is ready to give me a discounted price. Now, first, and the cost of carrying the inventory is given as 16% of average inventory value. This is the data. Here I have assumed 20 rupees as ordering cost. Now, as a first step of this particular process, I have to calculate different EOQs. This is step 1. So, I am calculating in this case, because three prices are given, P1, P2, P3. So, I can say that EOQ 1 is basically corresponding to P1, EOQ 2 is corresponding to P2, and EOQ 3 is corresponding to P3. With these three prices, I am calculating EOQs using the same formula under root 2 RCP upon CH. You see, in the numerator there is no change, under root 2 R into CP upon CH. So, in numerator there will be no change, R is constant, annual requirement, the ordering cost is also constant, 20 rupees per order. CH will vary, because one is 2 rupees, another CH is will be calculated for 1 rupee 90 paisa, and third CH will be calculated at 1 rupee 86 paisa. CH is 16% of material price. So, 0.16 into 2, 0.16 into 1.90, 0.16 into 1.86, these will be the values in my denominators. So, accordingly the calculation tells me 500, 513 and 519, these are the three EOQs. But now you can see, if I am charging 1 rupee 90 paisa, the minimum order quantity expected is 1000, but here my EOQ is coming 513, which is less than 1000. So, the supplier will say, hold, you will not be getting the benefit of 1 rupee 90 paisa. If you are giving me order of 513, I will charge you rupees 2. So, he will say, I have nothing to do with your EOQ calculations. I will charge what is as per my policy. So, according to supplier, this is invalid EOQ, because this is not falling in the prescribed range for which price 1 rupee 90 paisa is applicable. And similarly, our third EOQ is also invalid. This is also invalid EOQ. So, both these are invalid EOQs, 513 and 519, and only one valid EOQ I could find, that is 500 units. Now, based on these things, I will calculate my total inventory cost, that is at three particular levels. One is at 500, another at 1000, where I am getting a price break, and third is at 2000. The rule we see is that we have to calculate the total cost at all valid EOQs and at all price breaks. So, in this case, so we have three EOQs, 500, 513 and 519. These two are invalid, only 500 is valid. Valid, invalid because of price ranges on which that particular price is applicable. So, identify only valid EOQs, that is 500, and then we have to calculate total cost at all valid EOQ, that is 500, only one valid EOQ, and we have two price breaks in this particular case. One price break is at 1000 and another price break is at 2000. So, in this way we have to calculate the total cost, that is at 500, TC at 1000 and total cost at 2000, and that calculations are already available to us on this particular slide at 500 level, at 1000 level and at 2000 level, and here we see that these are coming 4160, 3992 and 4038. I can request all of you to try these calculations on your own. You can use Excel if you avoid calculators. So, you can use Excel and see that put the formula and get the values of these total cost. Out of these three total cost, the minimum cost is 3992 corresponding to quantity level of 1000. So, it becomes our order quantity. This is our order quantity, which is actually giving the benefit of lowest total cost. Here we are enjoying some benefits, not complete, some benefits of EOQ and the benefit of quantity discount. So, we have compromised, and when I say some benefit of quantity discount, I will request all of you that please explore why it is some benefit. You may recall our discussions of a class where we discussed that at EOQ level the holding cost and ordering cost are equal, but at this level TCQ equals to 3992. If you calculate the holding cost and ordering cost, they are not equal, but when we are taking the effect of quantity discount, this becomes the lowest cost and it is the order quantity for this particular case. Moving further, we have another important case, that is production lot sizing. As I said in the beginning, there may be situations where we are actually in our traditional models of EOQ, these vertical lines are the replenishment lines and these slanted lines are the consumption lines, but in some cases it is possible that our replenishment lines are like this and then the consumption lines like this and then the consumption line. And when we have these kind of angular replenishment lines, it means the replenishment and consumption happening simultaneously. The name indicates that only in the manufacturing facility, when we have a production facility, we have to discuss about production lot sizing, but any place where we have replenishment and consumption simultaneously, in that case this production lot sizing is applicable. Now, the rate of production is P and rate of consumption is R. So, the inventory, that means you are producing, let us say 10 units per day and you are consuming at the rate of 3 units per day. So, I can say that inventory is getting developed at the rate of P minus R, 7 units per day, that is the rate of inventory accumulation. So, in some time I am running this facility for T days and then I am using the inventory whatever we have built in these T days over D days, and T is is smaller than D. T is smaller than D generally because you are running your facility for 3 or 4 days and then you are consuming these over a 10 days period or 20 days period. And one more thing, P is the production rate is generally not only greater, but much greater than R, because if production rate is equal or less than R, no inventory accumulation will take place. So, these are the two important conditions for developing the production lot sizing or EPQ models. Now, here since entire discussion is similar to EOQ model, there is only one important change which you can directly see from this formula, that denominator term, here we have a multiplying factor of 1 minus R upon P. That is the only change we are having, that what is the rate of accumulation of inventory that is deciding the peak level. You see, my production quantity QP is the, in one lot I am going to produce QP items, but my average inventory is not going to be QP level. If I am producing QP, so QP will be the item I am consuming, QP will be the item I am consuming. So, average inventory in this case is QP by 2, but if QP is not produced over a day, QP is produced over some number of days, then what is going to happen? I am going to produce same QP, but these QPs are consumed like this. So, you are producing QP, but you are not touching these peaks. So, the height of this peak will be, this height of the peak will be QP into P minus R upon P. That is the height of the peak, and therefore, the average inventory in the case of EPQ is QP into P minus R upon 2P, that is the height. And therefore, this is, we already know, is the annual ordering cost. This will be our, because of this discussion, it will be our annual holding cost, and that is our QP cost. So, with this, different type of models which are possible in our inventory discussions, and we discussed 3 important models in this particular class, where we discussed that how you are going to handle the supply side uncertainty, and then with the help of example we saw that a complex case where supply side as well as demand side uncertainties were there. We also discussed quantity discount case, which are very common in bigger purchases, and then we also discussed that where your replenishment is not instant, replenishment is happening over a period of time, and during the period of replenishment consumption is also happening simultaneously. What should be the order quantity and what will be the maximum order level in these situations. So, with this we come to end of this session. Thank you very much.